Hello, can you see me? First thing that I notice is that my Sony black is not very good. I don't know if you hear my voice clearly. The other thing is, whether I'm moving back and forth or not, my Sony black, it just kind of refocuses, zooms, and some kind of, yeah, so just bear with it. Sorry about that. Okay, everybody, good morning class, 8th period class, good afternoon. I don't know, today turned out to be something Friday. We have different topics for each one, so deal with it. I don't know what club starts with the letter F, but quote of the day. It's kind of thought-provoking, and then interesting fact of the day. Okay, ready? So we did everything up here. There is one thing that I did want you to add, and that's this guy over here. You know how you have 1 minus the probability of the event? Can you kind of add that the probability of the event would also be the same thing as 1 minus what? The probability of not event. It's just switching the equation around. Okay? Alright, let's do the 4 problems. The very first problem is the very obvious, traditional, classic probability problem that you have been doing over and over again, probably from 6th grade. Number 2, 3, and 4 is the beginning of like, right? Okay? Alright, read the problem. So the probability of you picking a yellow would be the desired outcomes, which is 5 yellow, out of the total 5 plus 6 blue plus 4 white. That gives me 5 out of 15, which is 1 out of 3. Right? Okay. The odds would be, the odds of picking a yellow would be the desired outcomes 5, and then the stuff that you don't want, which is the 6 blue with the 4 white, giving me 5 out of 10, which is a half. Okay? Or you could also do it this way, and most likely you will do it this way. Looking at the final simplified fraction of probability, the desired outcome is 1. 3 represents the total outcomes. So then the undesired, the stuff that you don't want, would be 3 minus the stuff that you want, which is 1 out of 2, and you get the exact same answer again. Okay, these are supposed to be obvious. By the way, we say that's 1 out of 3. This one we say 1 to 2. Okay? Alright, are you with me? You might want to take a 30-second break and take a deep breath, because this is the beginning of like, what the hey? Alright, read the problem to yourself. If you want to pause, you can pause. I assume you did. Here we go. So, a circuit board has 20 computer chips. It looks like 5 of them are defective. So now the question is, if I was to randomly choose 3 out of those 20, what's the probability and odds that all 3 are defective? Anytime you pick more than one item randomly, this is the beginning of, most of the time, combination. Okay? When you're only picking one, the problem is a very simple process. It's when you're picking more than one, you have to kind of ask, well, how many different ways can I pick 3 computer chips from 20? I could pick the first one, the third one, the 8th one. But then I can pick the second one, the first one, the 4th one. How many different ways? Okay? By the way, it's how many different groups. It's not permutation. I've very rarely ever seen, I guess it's because they don't make problems that deal with permutations. But, okay. So, the probability of all 3 being defective would be, hold on for a second, I need my answer key. It is much easier to always figure out the total possibility of all the ways of picking 3 chips out of 20. Okay? So, what are all the different ways I can group 3 chips out of 20? That's combination of 20 chips taken 3 at a time. And now, what are the desired possibilities? Out of 5 defective ones, what are all the different ways that I could pick 3? You have to focus on the defective ones because your desired outcomes are all defective, and you have to ask, out of those 5, how many different ways, how many different groups of 3 chips can I pick at a time? And that's combination of 5 defective ones taken 3 at a time. I hope this is making sense to you. Okay? Okay, if you do that on the calculator, you should get 10 out of 114. Oopsie daisy. Out of 1,140, which reduces to 1 out of 114. The odds would then be the stuff that you want out of the stuff that you don't want, which is all the stuff minus 1, which would be 1 over 113. Again, the stuff that you don't want would be all the stuff minus the stuff that you want, which is the leftover stuff that you don't want. Sounds good? By the way, this is my second time doing this because I messed up over here. But life goes on. Alrighty. You might want to take a 1-minute break and kind of like soak it in and try to, you know, like, I don't know the word for it, but you know, try to like understand, digest, take it in. Number 3 is slightly more difficult because it's not all of them being defective. In this case, all of them being the A students. All right, read the problem by yourself. You might want to pause or something. And we're back. Okay. So in a class of, can you see me? I really hope you can see me because I'm not doing this for the 3rd time. So in a class of 27 students, 8 of them are getting A's. If I was to pick 5 students at random, what's the probability that 3 of them will be getting A's and 2 won't be? Here we go. So the probability that we're going to have 3 A's and 2 not A would be, it is always easier to figure out the total possibility of all the different ways of picking 5 students from 27. Okay? So, what are all the possible outcomes of taking 27 students, grouping them 5 at a time? That's a combination of 27, choose 5. And now, what are all the different ways of picking 3 students that are getting A's? You must focus just on the students that are getting A's. There are 8 students getting A's. So you are asking, what are all the different ways I could combine, I could group 3 of those students out of 8? And then we got the leftover 2. Now you have to go to all the students that are not getting the A's. So if there's 27 students getting A's, if there are 27 students, 8 getting A's, then how many would not be? The rest of the 19 students, 28 minus 7. Is 28 minus 7? I meant 27 minus 8. Oh, shoot. Anyways, the rest of the 19 students would not be getting A's, and now you have to ask, what are all the different ways I could combine 2 of those 19 students at a time? That's combination of 19 students taken 2 at a time. Counting principle says, if you want to know all the different ways of picking 3 A students and 2 not A students, multiply all the different ways of picking 3 A's and all the different ways of picking 2 A's. So that would be multiply right there. Sorry for keep getting the 27 and the 28 kind of confused back and forth. Alright? Alright, if you do the whole thing on the calculator, according to my calculation, which I really hope is correct, and you do the math inter on that, I get 1,064 out of 4,485. The odds would be the desired 1064 divided by the total 4485 minus the desired 1064, giving you the leftover undesired, which is 3421. Can you hear me okay? Should I raise my voice? All right, 1 minute break. Digest, take it in, discuss, think, pair, share. Am I going too fast? Okay. Oh, you could always rewind. Gosh, the benefits of technology. Alrighty. Finally, the last question. When you see the words at least, at most, things like that, this is the beginning of probability becoming a very tedious, rigorous, long kind of problems. Because, did you read the problem? Yeah, read the problem. Okay, so if you read the problem, they're asking you, if you were to, pick a poker hand, not a poker hand, but if you were to pick 5 out of 52 cards, what's the probability that at least one of those cards will be a face card? That means you would have to calculate the probability of picking 1 face card, calculate the probability of picking 2 face cards, 3 face cards, 4 face cards, and all 5 face cards, and then you have to do some sort of an operation of adding or multiplying them, which later on you should realize you're supposed to add them. That's a lot of stuff. However, you could rethink this problem as, why don't we think of what is the probability of getting absolutely no face cards, and then say the opposite of that would be the probability of getting at least 1 face card. So we could think of this problem of probability of getting at least 1 face card as 1 minus, I ran out of room, great. 1 minus the probability, 1 minus the probability of getting absolutely no face cards, okay? You kind of have to understand the probability of getting absolutely no face card is the exact opposite, they call it complement by the way, exact opposite of probability of getting at least 1 face card. If you figure out the probability of getting no face card and you take 1 minus that, then this is the probability of getting at least 1 face card. This is the probability of an event happening. This is the probability of the event not happening. 1 minus that event will give you the other one. Okay? So that turns out to be 1 minus. What is the probability of having absolutely no face card? Once again, let's do all the total outcomes, which would be combination of 52 choosing 5 at a time. And now on top, what are all the ways that you could group no face cards? How many non-face cards are there? Well, there's Jack, Queen, King. These are the 3 face cards, but there's like each suit, there's like 3 of those diamonds, 3 hearts, 3 clubs, and 3 spades. So there's 12 face cards, which means the remaining 52 minus 12, which is 40, you are asking out of the 40 non-face cards, how many different ways can I choose 5 at a time? Whew. Okay. If you were to do that, I end up getting, whoa, hopefully my calculations are right. My numerator was 658,008, and my denominator is the usual stuff that you have seen in other problems. I think I did not write that right. 2,598,960. I hope that's right. Okay. And if you were to do all that, 1 minus, and then do math enter, I got 6,221 out of 8,330. So then the odds would be the desired 6221 divided by A330. The total minus the desired 6221, which gives me 2109. 6221 divided by 2109. Okay? No, please don't. Alright. If any of this was confusing, you could always go back and rewind and replay. If not, your homework is a bit easier, at least towards the beginning. So, at least at the beginning. Alright. Good luck on the worksheet. Start. Do them on a separate sheet of paper. And in the last minute or two before the bell, replay. Are you replaying? Okay, ready? Go! Okay, thank you. Come again. Everybody have a nice weekend. Bye-bye.